first we're going to simplify the equations, then we are going to solve. So for this first one, I just combine the like terms on the left-hand side, get 4y equals 40. So then I can divide by 4 on each side. Y equals 10. For the next one, it's already as simplified as it can be. So I'm going to add p to each side. So I have 6p plus 28 equals 88. And I'm going to subtract 28 from each side, making sure I show that that's what I'm doing on each side. 6p equals 60 divided by 6 on each side. P equals 10. Is my final solution. I don't really like the way that's written because it almost implies that this is the next one. Even though it has the solution line there. I'm just going to keep it over here. For the next one, I do need to combine like terms first. So 5b equals 65. And divide by 5 on each side. b equals 13. Problem number 4. I already have it in simplest form on the left-hand side and the right-hand side. So I'm going to add e to each side. 13e minus the 19 equals the 7. That's remaining on the right-hand side. So then I'm going to add 19 to each side. And I get that 13 equals 26. So that when I divide by 13 on each side, I find that e will equal 2. For problem number 15, I threw some fractions at me. If I have 3n and a half n, I altogether have 3.5n equals 42. At this point, our typical strategy is to divide by 3.5. So n equals 42 over 1 divided by 7 over 2. So 42 over 1 times 2 over 7. Simplify before I multiply, I get 6 times 2. So n equals 12. Some people try with all their might to avoid fractions. So another option on what to do once you have your simplified fraction would be to double each side. Now if there was more than just the 42 on the right hand side or more than just the 3.5n on the left hand side, you'd have to double every single term that's involved. In this case it just becomes 7n equals 84 divided by 7 divided by 7, you get the n equals 12 by that method as well. For this next one I'm going to combine like terms. Some people do their variable terms and their constant terms as separate steps, which is fine. But you could do it in one step on combining the two m terms and combining the two constant terms on the left-hand side. And on the right-hand side, I'm combining the two constant terms. Now I just have a two-step equation, so I'm going to undo the adding 5 by subtracting 5 on both sides. So 4m equals negative 12. I'm going to undo the multiplying by 4 dividing by 4 and 4 on each side to find that m equals negative 3. I'm going to pause it while I clear the ink and scroll it. Alright, here we have problem number 7. We have distributive property needed. 3 plus 6y equals, on the right hand side I don't need to use the distributive property. I can combine my like terms. So I've got the 4y and the 2y is 6y, and then I can just count up one more to get my 7y. Typically when I have more than two terms I do have to do it in steps, but adding one more is just one more finger up kind of thing. So 6, oops, and then one more 7. So it's just a counting thing at that point. I'm going to subtract 6y from each side, and 3 equals y is right there my solution. Problem number 8. Let's see, on the left-hand side I don't have anything to simplify, but on the right-hand side I do have distributive property because that 6 is on the outside of an addition expression. I'm going to add 12x to each side so I can end up with a positive coefficient because I like that lots. 8 equals 6 plus 18x. I'm going to subtract 6 from each side. 2 equals 18x. I'm going to divide by 18 on each side, and x equals 1/9. So that would be my solution. X equals 1/9. If you were doing it with division, you might have gone with the decimal root, which would be 0.1111 repeated. Problem number 9. Here we go, combining like terms. Negative 4.8 has nothing to combine with, but the 1b and the 0.6b can combine to make 1.6b. Oh, I'm not lined up anymore. Equals 1.8 plus 3.6b. I like to keep positive coefficients, so I'm going to get rid of my 1.6b on each side and end up with negative 4.8 equals 1.8 plus 2b. And then I'm going to subtract 1.8 on each side. I remember getting all giddy thinking, oh good, I'm going to get rid of my decimal. Oh no, I don't. Because now that I'm subtracting 1.8 from negative 4.8, I just get a bigger negative. Negative 6.6, I believe. Yep. Equals 2b. Divide by 2 on each side. b equals negative 3.3. Problem number 10, it looks like it doesn't need to be simplified at all before I start solving it, so that's good. 3t minus 5 equals 7, plus 5 on each side, 3t equals 12. Now divide by 3 on each side, and find that t equals 4. That would be the solution for problem number 10. I'm going to pause it while I get to the next page. I'm only going to do the next 4 problems. I'm not going to do the checking if equations are equivalent. First one I could check because I could simplify each of them and simplify to the same thing. The next one, you can't even do that. You have to actually find the solution. And if they have the same solution, then they end up being equivalent. But problem number 11, let's focus on that. We want to focus on simplifying and solving. So for this one, I am going to get rid of a b on each side. 7b minus the 25. Positive 7b. Alright, do over on that one. Minus 25 equals 80. Plus 25 on each side. So 7b equals 105. Divide by 7, divide by 7. b equals 15. When I did it my first time, I think I did long division to make sure of that. Next one, I do need to combine my terms first, but only on the left-hand side. Now I can add z to each side and get 10z equals 60. Divide by 10 on each side, z has to equal 6. Problem number 13. Combine those like terms first. So 4g plus 32 equals 29 plus 5g. I'm going to get rid of 4g on each side. And get 32 equals 29 plus a g. So I do need to subtract 29 on each side. I'm run out of room, unfortunately. So I'm going to go down below here and find that 3 equals g. I don't have to have another step because I already got it to what a single g is worth back when I subtracted 4g. And the last one for this recording, 16 plus I have 1s left equals 4. It's 24 rather, minus 20 gives me 4 left over plus 2s. I'm going to subtract s from each side. 16 equals 4 plus what s I have left over, minus 4 on each side. 12 equals s is my solution. And done.